Good morning, everybody. This is Josh Valentine, Communications Manager for the Clean Coalition. Thanks for attending today's webinar. Just a few things to go over before we begin. If you look on your screen there, if you have a question and you'd like to submit for the Q&A portion at the end of the presentation, please submit in the control panel of GoToWebinar. It sometimes varies on how it looks based on your operating system, but you'll see there on the screen where to do it. We will have about 15 minutes for a Q&A session, and we'll try to get to most of your questions. The webinar recording and slides will be sent to registered attendees within 2 business days, and we usually get them out in one, so you'll be sending that out tomorrow that you can share around on social media or email to your colleagues. All webinars are archived on our website, so it'll basically have a link to there, and that is a link to our YouTube channel where they are hosted. If you have any general questions about the Clean Coalition, our work, or our webinars, contact me at josh@clean-coalition.org. Coming up, before we get started, I wanted to show you we have another webinar coming up on March 18th, identifying optimal locations for community microgrids, and that's going to be presented by our very own Gregory Young. So there is a link on our website. We will be sending an email reminders about that, but you can go on our website, hit the register now button, and register for that webinar on March 18th. So today we have a webinar, SDG&E, state-of-the-art energy storage and microgrid systems, and Kirsten Petersen from SDG&E is going to be presenting. Kirsten is a senior engineer in the Distributed Energy Resources Group at SDG&E. In her role, she supports the integration and operation of utility-owned energy storage and microgrid systems through dynamic modeling and hardware testing. Her background is in system protection, which she applies to the automation and the communication between energy controllers and the point of interconnection. So I'm going to pass it off to Kirsten now, and she'll go ahead with her presentation.
Okay. Well, thank you very much for the introduction, Josh. So good afternoon, everyone. Greetings from San Diego Gas and Electric. I see we have participants from all over today. So I'm looking forward to sharing with you all about some of what we're doing at SDG&E with energy storage and microgrids. So let's get started. So for those of you who know about San Diego, maybe from here, I know it always brings up images of beaches, Balboa Park, the San Diego Zoo, and hopefully now it also makes you think energy storage. So the picture we have on the screen right now shows some of San Diego Gas and Electric's energy storage installations currently installed and in use on our service territory. So right now there's 7 of these large-scale projects. In total, they are about 45 megawatts. And even not pictured here, we have an additional about 20 megawatts of smaller scale solar, some behind the meter on the secondary side even. So today, specifically, we're going to be looking at 3 of these energy storage systems. So I'll be taking you on a tour around San Diego County, stopping at our Carmel Valley Energy Storage site, checking out our Borrego Springs Microgrid, and then ending at the Miguel Energy Storage site. And luckily through this, looks like we get to shave off about 4.5 hours of drive time. So yeah, so I hope you enjoy. And if there's any questions along the way, please submit them through the web portal. I'm going to start with a little bit of background for those of you less familiar with San Diego Gas and Electric. We're a subsidiary of Sempra Energy, and we are one of the 3 investor-owned utilities in the state of California. So you can see our service territory down there in the southwest corner. We span from the border with Mexico, go up to the Orange County border and then as far east as Imperial Valley. And that's about 4,100 square miles. And in that pocket, we have 3.6 million customers, which we serve through 1.4 million smart electric meters. And on our gas side, we have about 873,000 natural gas meters. At our site, we have about 4,000 employees. So I guess that's almost one employee for a square mile, I was just realizing. And within that, we have about 300 engineers. I'm one of those engineers, so I know I already got that nice introduction from Josh, but you can see me with the rest of our distributed energy resources team. And we're the team that's working to bring energy storage into the San Diego Gas and Electric Service Territory, which is all striving toward California's goal to have the 100% free energy, carbon-free energy market by 2045. We'll talk a little bit about those goals later on. And a lot of what I'll work on the team is in the beginning stages of modeling our energy storage systems and testing them out in a test facility we have up in Escondido using real-time digital simulators. We have hardware in the loop testing. So before these systems get out in the field, or if there's any logic or automation changes, they'll first go through a lab setting and get tested and validated. So that's where I am usually found. And more recently, I've started on a team that's even looking at how we can use these energy storage as a way to provide reliable power for planned, unplanned outages, how we can help to mitigate impacts of PSPS. So it's a lot of good work going on in the teams, and yeah, let's dive right in. So as a utility in the state of California, we're in a unique position where we have a number of government mandates and also goals that are very aggressive, and that allows for opportunity for innovation, for really driving the direction of microgrids and energy storage. And one of those that I just want to highlight as we get started is Senate Bill 100. So that one is California's goal that by 2045, all 40 million residents will be served by electricity that is zero emission. And striving toward that goal, we have therefore to also meet challenges like the growing demand for electric vehicle charging as we increase the number of EVs out on our system. We want to do so without impacting electricity costs, or with the goal of addressing high electricity costs, and also integrating higher penetration of renewables, because that ultimately is what will meet those zero emissions. So right now, San Diego is currently leading in meeting these goals in the state. We're at about 45% renewable energy mix. And then even within that, our load pocket, we have 175,000 private solar systems, and that generates peak megawatts of, or 1,200 megawatts. So even just from customer generation side, we have a very high percentage of solar right now. Our San Diego drivers have approximately 52,000 plug-in electric vehicles within our region, so that contributes to our demand and the need for infrastructure for to charge these electric vehicles and provide the electricity for that load. In addition to Senate Bill 100, I just wanted to point out a few others to keep in mind, which is the CPUC mandate AB 2514. So that one set a lot of the initial deployment targets in California, It's split between transmission, distribution, and customer domains, and SDG&E is playing with within those fields. We have Senate Bill 1339. That one's facilitating the commercialization of microgrids, so how we can better pave the way for getting microgrids connected to our systems at the utility level. We have the microgrid order instituting rulemaking. So that's what's helping the CPUC in consultation with the CEC and CalISO to undertake activities that are further developing these policies related to microgrids. And then in addition to that, distribution resource plan and the integrated distributed energy resources within that plan. So that's really laying the groundwork for evaluating and deploying DERs, as well as establishing the hosting capacity and what benefits we get out of those DERs. So in addition to these regulatory drivers, there's also a number of technical reasons why SDG&E is choosing to deploy energy storage in our service territory right now. So the battery, some of our batteries allow us to support the integration of renewables. So whether that be helping to condition the power, do PV smoothing, or just have the dual use energy storage and renewable resource like PV. And the adding batteries in that mix really helps improve the power quality, since we do have so much intermittency related to renewables getting added to our system. But reliability can be improved as well. So we have energy storage to support emergency operations, to support planned outages, providing backup power in these situations, and really ultimately giving us the ability to ride through outages, whether they be planned or unplanned. So SDG&E also has been working in the energy market. So there's the ability to use energy storage at a CAISO market level and support dual use, where the battery may participate in the market, but also serve these reliability and power quality situations that we just went through. All right, so this slide outlines a few of the topologies of deployments, some that we currently have at SDG&E and what you might see out on the utility scale battery system. The first one is substation energy storage. So if you hear the acronym SES, that's what that's referring to. These batteries are typically adjacent to substations, and we have them either interconnecting at the distribution or transmission level, depending on its purpose. And these batteries are typically larger scale than, say, the next on their list, which is the community energy storage. So these community energy storage batteries, maybe they're just connected to a few houses that have solar. We have some that exist right now for that purpose, for both smoothing the power, but also providing backup for power interruptions. And then we have market energy storage systems. So these ones are typically those substation energy storage system level, and they're able to actually participate in the CAISO marketplace. Then this last box we have on here, distributed resource aggregations. If we have SES systems and CS systems deployed, we're able to actually aggregate those and could bundle them for market participation. So have these systems through management systems able to serve as a single energy storage installation for market participation purposes. Okay, so our first stop on exploring some of these SDG&E energy storage locations is going to be the Carmel Valley Energy Storage System. So this location, it's about a half hour north of downtown Seattle in a community called Carmel Valley, and specifically at school, the Canyon Crest Academy. So this system's a personal interest of mine because, like Josh mentioned, my background's in system protection, and while I was on that team, I worked on the automation and logic of this, and then now being in distributed energy resources, I get to continue work on this system and continue improving its ability to serve our community. All right, here we have a picture of, if you were to go to the site of our Carmel Valley storage system, those are two of the battery containers. Carmel Valley is of the lithium-ion chemistry for the batteries, and it's capable of dispatching 1 megawatt, and that allows us for 3 megawatt hours of energy to be provided. What's unique about this system is that it's specifically serving a critical customer, which for us is an emergency evacuation center at the school. So the school's gymnasium, if we were to need an emergency evacuation center, that is critical for us to keep it energized. So what this battery system does is, in the event of an outage, the battery system seamlessly takes over that the load of the gymnasium, and that customer will not see any detectable interruption of power. So that's what we call seamlessly islanding. So essentially creating now a smaller version of the grid that is just the energy storage system and the critical customer, which is the grid, which is the gymnasium. This site is also important to note that it does have smart inverters, so it's able to actually integrate the solar that's already existing at the school. They have a number of solar installations on their parking garage, and utilize that to extend the length of how long we can energize the gymnasium using this energy storage installation. So here's an aerial view. These are the 4 battery containers in our microgrid yard. They're 250 kilowatts each, 750 kilowatt hours total. So that's how in unison we're able to get that 1 megawatt, 3 megawatt hours. We have a switch down here in the southern part of the yard where we interconnect with this SDG&E grid and this gymnasium, which is off here to the left. So all of this system you see here, it's able to be monitored and controlled either locally through a control system that's within one of these containers, or our operations center in San Diego is able to do the communication through our distributed energy resource management system. So we don't have to be on site to be able to monitor and operate this system. It can be controlled by our operators as well. So its ability to go into that islanded state where it's energizing the gymnasium, that's automatically triggered if the battery system senses that the power has gone out. So here's just a one line to show what is electrically connected on our system. This represents the energy storage systems. You see our transformers to get our power up to 12, or voltage up to 12 kV, like the rest of SDG&E's grid. And this is the critical piece here, which is that 4-way switch shown here. And that allows us to electrically isolate our energy storage system and our critical load at the school from the source, which is the substation and SDG&E's grid, and then any non-critical loads that we do not have within our island. So this whole portion here on the left, the energy storage and the critical load, if we lose the grid, have an outage, this is what will remain energized. All right, so we're going to move on to our second stop, which is the Borrego Springs Microgrid. So you might have heard of our Borrego Springs Microgrid. It's definitely one of our flagship projects here at SDG&E. So this microgrid, it's a storage-supported microgrid solution, and it's serving a very small, isolated desert community, and we've had it in operation since 2010. So up on the screen, I just have the DOE definition of microgrid, because it is slightly different than the Carmel Valley being just primarily the energy storage serving a single load. This actually you could think of as sort of a miniature version of the grid, where you have a number of interconnected loads and distributed energy resources, so batteries, solar, as well as this one has a generator on site too, which we are working to phase out so that it can be without any carbon emitting sources. So this island serves as a single controllable entity. So we have that controller mentioned for Carmel Valley also present here, where the operators are able to remotely control this microgrid without having to send someone to the site, which is really helpful if we have planned maintenance or anything where we don't want the community of Borrego to experience an outage. So why did we pick Borrego Springs? The community of Borrego, like I mentioned, is very small, isolated in that northeast corner of San Diego County. And something very unique about it is it's fed by only a single sub-transmission line. So this is a radial line, which means if for any reason we didn't have that line energized, or if we needed to de-energize it, there would be no other source of power for Borrego. So that made it a very prime candidate for having a microgrid where it can operate independently from the rest of the grid. Borrego is a very progressive community, which helps. Whenever we're out there, we always get a lot of feedback, interest from the local community, and we are always sharing what is going on in terms of improvements to the microgrid, if it will impact customers at all. And also being in the middle of the desert in this valley, like you see in the picture, the possibilities for solar are very high. So a lot of customers have solar. We have 4.3 megawatts of customer generation, as well as 2 solar facilities. There's one transmission level at 26 megawatts. That's Clearway's Borrego Solar. And then there's also a distribution solar plant that's 6 megawatts. This location allowed for a lot of potential for reliability enhancements, as well as the opportunity to balance supply and demand and make this load pocket more self-sufficient. And they're using a lot of the locally generated power. So this project uses a number of advanced technologies that help to provide this additional resiliency and allow us to actually power now the entire community, which is 2,800 customers, during planned grid maintenance, during forced outages. So this allows us to mitigate any service interruptions for these customers. The microgrid yard itself, there's some images on the right of what we have. There's battery storage. We have a system that's 1 megawatt and 3 megawatt hours, so similar to the one at Carmel Valley. There's also a 0.5 megawatt, 1.5 megawatt hour battery system. And then within the community, we have those community energy storage batteries, so the secondary connected batteries we mentioned a little bit earlier. There's the solar plants distributed throughout the community of Borrego. And in addition, there's currently 2 megawatt diesel generators that allow us to additionally extend the life of the island if needed. And we're working to create a 100% renewable microgrid. And also there is a 0.25 megawatt ultra cap. So this is one of the more recent additions that we're incorporating into our microgrid system. You can see here that the one line for Borrego is a bit more complex than we had at Carmel Valley, and that is because of it being a full-scale microgrid. We have the distributed solar, we have the solar facilities shown on here where they interconnect. All of the circuits are able to be energized by Borrego, but we can actually using the grid isolation switches. So there's one here. Oops, there's one on the 12 kV bus, one on the 69 kV bus. Depending on how we configure our microgrid, we can either energize a single circuit, so that circuit one you see down here, we can energize everything connected to the 12 kV bus, which is all three customer circuits. And we also have the ability to energize up to this 69 kV bus, where we're able to bring in this Clearway solar facility and keep the entire community of Borrego energized. So there's a lot of versatility with this microgrid, and our control systems really allows us to customize for the need, how we're going to operate. And now we're just going to look a little bit closer at those community energy storage systems in Borrego. So one of the battery examples is down here in the bottom left. These batteries will typically be connected to, there's 3 of them deployed, and they all have connected on the underground secondary side with houses that have solar installations on the roof. So this allows for a smaller segment. If for some reason, we didn't have the microgrid running and the town was to experience an outage, the customers that have these community energy storage systems, they're able to ride through the outages. And we've had use cases in the field where we can prove that. But another purpose they serve for your day-to-day when they're not being utilized for resiliency is the concept of PV smoothing. So that's the one that we're just highlighting on this slide. This energy storage in conjunction with the intermittency of solar is able to charge and discharge to smooth the output that's actually seen by the SDG&E grid. So by the time that solar energy reaches our 12 kV lines, the battery has been able to fill in some of those gaps that are caused by clouds going over or by really just anything that would impact the smooth output of a solar site. So this red line's just the straight output of a solar installation on one of the roofs. And then after the charging and discharging of the battery, to fill in all of these like dips you see, this blue line is what the grid is actually experiencing. So you can see it's a lot more smooth output, not jumping up and down, causing unnecessary harmonics or anything. It really helps on receiving the best quality of power on the 12 kV side. Okay, so now we're going to leave the Borrego Desert and head out to the Miguel Energy Storage site. So this is a unique situation in that the Japanese government, via an organization called NITO, so they're like the equivalent of the DOE in Japan, they were working with a manufacturer of vanadium redox flow batteries called Sumitomo Electric, and they sought out SDG&E to partner with for a demonstration project to showcase their technology. So this is the first of their installations to showcase in the United States. A grant was provided with Sumitomo to manufacture, install the battery. SDG&E selected a site for this battery and was able to provide this system to interconnect it to our system and support a number of use cases to really prove out the technology, see if it's something we want to deploy long-term, add to the current portfolio of energy storage options in addition to lithium-ion on our system. So this system's connected on the 12 kV level. It's actually at the end of one of our circuits, so it's a unique position, but this particular circuit has high PV penetration, as well as an increasing load toward the end of the circuit. So it allows us to, maybe defer other projects because this battery can come in and provide additional functions to support that load. The battery we have installed right now is 2 megawatts. It's 4 megawatt hours, for 4 hours. And there's 2 banks of batteries. So basically like a cookie cutter copy of each of the systems. So you can see them down here in the bottom left. These are the 2 systems. All right, and here's just a little bit on what makes the vanadium redox flow batteries special. These batteries use a chemical energy to generate electricity, and this process here is called redox, and it's a combination of reduction and oxidation. So this chemical process that the batteries undergo, this is what actually allows the vanadium ions to undergo oxidation conditions, and this stores the potential energy. So the vanadium ions are dissolved in an electrolyte, and this electrolyte goes through cell stacks where the chemical energy is stored, or it's converted to electricity. And then there's tanks of these electrolytes where the energy is stored. And definitely, as not a chemical engineer, my experience beyond this chemical process, still working on going through it, but this is just a high level how that exchange takes place. So as we're analyzing this system, it's really a great use case for us to validate lithium-ion as an alternative to VRF as an alternative to lithium-ion, since so far the rest of our service territory batteries are lithium-ion. So it's good to have some alternatives. There's a lot of aspects of these batteries that are exciting to us. For one, they have a very long lifespan. It's expected over 20 years, and there's no limit to charging. So there's no degradation when the charge and discharge cycles occur. These batteries are very fast responding and serve long duration purposes. And one thing that's particularly exciting to us about this technology is its inherent non-combustibility. So we see this as a very viable option for areas where there might be fire risk or out in the backcountry, and it's looking like a very promising technology and huge benefit with the non-combustibility. We find this to be suitable for multiple use cases, so integrating renewables, but also participating in the CalISO market. And this site is one where we do participate with CalISO. And it serves similar to, even on the smaller scale, those community energy resource batteries. This can help with fluctuations in generation or needed deferrals because of increased load at the end of circuit, particularly where this system is located. All right, and that actually completes our tour of those 3 energy storage sites this afternoon. Those 3 you saw were only a fraction of the energy storage in our service territory, so there's definitely more we could cover in the future, but I hope that getting a snapshot of those 3 has helped give a glimpse of what SDG&E currently has on our system, and what we're using to help shape the future of our energy storage within the San Diego service territory. We covered some of the industry and state regulation drivers, and those continue to be in place and helping us to continue adopting these solutions and also putting research towards these solutions through our testing infrastructure and field experience. And all of this is helping us strive toward that 100% zero emission energy climate of the future. So that covers it for our subject matter today, but now seems like a good time to go into questions and answers if some of those have been coming in.
Thank you, Kirsten. We do have a lot of questions coming in, so we got plenty of time to answer them. Thanks for the great presentation and the tour. So let's get right to it. We have a question from Pranab Viparkur, a senior system integration engineer at Amber Kinetics. Pranav asks, can you comment on the frequency regulation market and how many battery cycles per day do you expect to happen for regulating frequency?
Yeah, I think on some of those specifics, we might need to take those offline, and I can follow up with, once we confirm more specific details on that.
Sure.
Sorry, I do not have that one off the top of my head.
Okay. Genevieve Liang asks, actually, she wants a clarification on what utility-owned means. Were all SDG&E solar plus energy storage projects procured through specified RFPs issued by the utility and developed and built by third parties, or were any developed and built internally by SDG&E?
So the ones that we talked about today, those are by utility owned. It's ones that SDG&E has gone through either the process of applying for projects, applying for DOE funding studies, and by owned and operated, they're ones that we currently, all maintenance is done through SDG&E. Our engineers and operators are the ones who will use and deploy the systems when they need to be utilized, and all modifications go through the company. So we do have, I guess one thing to point out on that is like the Borrego Microgrid. SDG&E doesn't own the solar facilities. Like Clearway owns that 26 megawatt one we were talking about. The other is Desert Green. It's also privately owned, but we have agreements in place with them on how we use and interact with them in the microgrid scenario, because depending on the load too, we might not necessarily need to utilize the PV, or we might, so we have agreements for how we would curtail them, or if we, or not basically, or if we need to trip one offline. Those are all operating procedures that we've worked on in conjunction. So whereas in this is going back to the one line for Borrego, the microgrid assets box here, that's like our actual SDG&E yard. We, SDG&E, are the owners of these energy storage systems, of the generators, and then all associated like infrastructure on the 12 kV circuit side.
Great, thank you. Lane Sherman, the Executive Director at San Diego Energy District Foundation, asks, Lane states, as a co-founder of the San Diego Community Choice Movement, I'm interested in how SDG&E and the emerging CCAs can cooperate to develop community-scale storage projects serving key loads like you did in Carmel Valley.
So we're looking forward to working closely with all the local agencies, but for resiliency. But guess as a personal, engineer, like I can't or don't have a direct comment on that, other than looking forward to the conversations to come.
Sure,
Oh,
thanks.
and also, I guess just a note on, we do welcome input on that. So if there is anything that would be helpful to share, definitely this could be a venue to make connections.
Sure. Mandy Lee has a multi-part question, so let me know if you need me to repeat anything. Mandy asks, what is your approach to racial equity in your innovations? Will renewables, microgrids, storage, and EV infrastructure reduce costs for ratepayers in the most cost-burdened communities? And are you prioritizing low-income households and communities of color who bear the highest energy cost burden when you choose where and how to implement grid improvements?
Okay. So do you actually mind just going through that one more time? And then
Yeah.
I think I was jotting down some.
Sure. Mandy asked, what is your approach to racial equity in your innovations? Will renewables and microgrids, storage, and EV infrastructure reduce costs for ratepayers in the most cost-burdened communities? And are you prioritizing low-income households and communities of color who bear the highest energy cost burden when you choose where and how to implement grid improvements?
All right. So as we are scoping out new projects, looking for new ones to propose location-wise, we do have like a large breadth of considerations we take in. We look at specifically areas where we might need community resource centers, where what might typically be like an underserved community, looking basically to, I guess, as you've addressed, there's a number of factors that come in, especially with who is most impacted by situations such as if we have to go through a PSPS event, in these high wind scenarios. So we're definitely targeting areas that are at the most critical. And so we have teams in place that are really researching from a community perspective and also from a technical perspective, how those come together. So even, I guess, looking at PSPS scenarios, those for the most part are occurring in our backcountry where it's the hottest, where it's the farthest from the maybe resources like that, critical resources. So we have a number of teams right now studying those areas, going out to the communities and working with local representatives and determining who could best be served by these solutions.
All right, thank you. We've got some questions on Borrego Springs. This one from Kevin Dillon, a clean energy specialist for the New Jersey Board of Public Utilities. Kevin asked, does Borrego Springs cross more than one right-of-way? And if so, how did you deal with any regulatory issues to complete the project? And what was the procurement and financing process like?
So I guess just one caveat is all of that happened before I joined the company 5 years ago, but I do have some information on specifically the is how that funding came to be. So we do have a grant through the DOE, which was a big driver in this project, and it continues to be something that we've applied for and gotten to be able to add infrastructure improvements to the Borrego Springs community. So it's the development is primarily through that source, and yeah, I guess. Yeah. Oh, and right, we are able, I guess another point is that we are able to use a lot of the local already existing infrastructure to help it be more cost effective. And I think too, just from a community perspective, like the feedback we get from the Borrego being so progressive too, is having them on board has really helped with a lot of what's driving to actually improve this system.
Great, thank you. And Malini from my organization, Clean Coalition, she's asking, well, you might have addressed this in the past question, but she's asking, can you talk about the economics of this project, Borrego Springs? For example, what is the cost of providing this service to the community? And how does it compare to the traditional method of service, i.e. building another high voltage line?
Yeah. So one thing that's, I guess, important on this project is, like we were mentioning, with the DOE being so interested in funding this project, is it is ultimately, like, without going into too many details on cost, it is ultimately a more cost-effective solution to build these microgrids rather than extending infrastructure of additional transmission lines, in addition to other impacts, like where if we can just improve the existing infrastructure or augment it rather than having to route an entirely additional line, which still inherently would have all the environmental impacts, land impacts, doesn't really help us if our goal is to not have energized lines going out to this site. So a lot of drivers such as that really support this being a microgrid solution rather than a added transition line solution, because they are so remote. In addition, like how we were talking about, California is really having great drives to get us to be 100% renewable. Is we see this as being a more sustainable option, like that the point about having the local, being able to utilize more local generation sources. So like if the town can produce the energy and use it locally versus importing from another state or elsewhere in California. Because a lot of times, especially with the amount of customer solar in Borrego, you don't necessarily, like, the solar is providing beyond that from those two Borrego sites that were listed. So it really makes it a more sustainable solution in that sense.
Great, thank you. Genevieve Liang asks on the Borrego project, what was the thinking behind the mix of the front of the meter battery sizes, not the CES assets?
So how the like the microgrid storage units were sized? Actually, do you mind just repeating it one more time? I think I got it.
Sure. She's asking, what was the thinking behind the mix of in front of meter battery sizes, not the CES assets?
Oh, so like why we have one that was 0.2 megawatts and then the other ones being 1.5. So this Borrego's really been built up in stages from its earliest inception with just the generators in this original AES system. Because at its start, Borrego was just energizing this. It was really a proof of concept, and we were only energizing this one circuit you see here. So it was a much smaller scale microgrid at the time. And this was the original energy storage application here. So it wasn't until we were able to, through the DOE grant process and other funding sources, we're able to build this system to where now, with the added energy storage, we could then pick up this entire 12 kV bus, and then from there, also this desert green solar here. It's sort of as the vision of Borrego grows, so does then the assets that are on it. So like if we were to go and build Borrego from the ground up today, maybe it would look different. But this has really been like as our sort of prime flagship opportunity is it's been growing and learning with us along the way. So then the most recent advancement is our third island topology, where we can go up to the 69 kV system and bring in the Clearway solar. That's drastically increased our ability to drive this microgrid to be a 100% renewable system. And we're actually working right now on this energy storage, the AES1 and 2 over here, having that actually be the asset that's driving and controlling the frequency and voltage of our microgrid rather than these generators, so that we can ultimately phase them out and have Borrego Springs be a clean energy microgrid.
Great, thank you. So one more question on the Borrego Springs comes from Kimberly Ott, a project manager at NREL. Kimberly asks, are the SAFT batteries from their recently acquired state up Go Electric?
What was the last, or actually, can you repeat that? I missed the last part.
Are the SAFT batteries from the recently acquired Go Electric?
Yeah, so I might have to follow up on that one. So the SAFT battery is the original, in the original Borrego installation. So back in like the 2010 realm. So it might be older, but I'm actually not familiar with that. So I'm going to have to look into Go Electric.
Sure. All right. So we have a couple we got a couple more minutes, so let's go over some more. There's a question from Gregory Young at the Clean Coalition. Gregory is asking, how much solar exists on a Gymnasium next to the Carmel battery? He also asks, does the Carmel energy storage cycle daily for TOU arbitrage and other economic optimizations?
Okay, for so Carmel Valley, and I'm embarrassed I'm blanking on how much solar is on there. They have the solar canopies over their parking lots. I can't remember. Yeah, I can share the specs with you on that. I apologize. I can't remember exactly what size the solar is. So adding that to the list of follow-up to confirm that. And then as far as how we're using it right now, so we have engineers that are scheduling the battery for like to dispatch, charge, discharge. Sometimes it's just running if we just need it to idle for in case we need to use it or keep it at a particular state of charge. We're not currently doing arbitrage with that, because that was what the question was on, right? Was if we were doing arbitrage. So we're not currently, but we have scheduled dispatch for it, and otherwise, like we have the ability to do like 4-quadrant operation. We've run tests through that, peak shaving, PV smoothing. But right now it is primarily for resiliency purposes, and then if for some reason we needed to schedule any discharge.
Okay, thanks. Sam White, who's a policy analyst at the Clean Coalition, has a couple of questions. So let me know if you need any of this repeated on Carmel Valley. Sam is asking, why is the power transformed to 12 kV when it is serving adjacent critical customer load? And how long will 3 megawatts per hour meet critical load demand, and how much is this extended by the on-site PV?
All right, so we do 12 kV interconnection just because so that we could use the other use cases except for just serving the load at the gymnasium. So far, we haven't had an issue with requiring additional time on the batteries, but what you can see on this switch where the batteries and the load and the source are interconnected, that we have this non-critical load, and we actually sometimes will just go ahead and pick up the non-critical depending on, you know, if the solar is already covering what the batteries are producing, what the school is using. We can bring in this non-critical load as well, because even since the inception of this project, there's been additional loads added. Like there's now an additional apartment complex on this now non-critical load side of the switch. So the automation of this switch actually allows us to choose to pick up both if we want to. So we haven't yet needed to like drop any additional load. It's been enough to cover the durations of outages we have gone through.
And then the final part of his question, Sam's question, is the storage used for grid services and market participation when it's not islanded?
This one is, we haven't used Carmel Valley for market participation. Of the ones that we looked at, the VRF is the one that we've been using for market participation.
Great. And Gregory Young, to tack on to his question regarding Carmel Valley, is asking, is the Carmel battery interconnected in front of the meter or behind the meter?
Is actually, you mind repeating that one? Sorry.
Sure, yeah. Is the Carmel battery interconnected in front of the meter or behind the meter?
Oh, it's in front of the meter, so on the SDG&E side. So it's actually connected through a 12 kV switch, which is like a standard isolation switch that we use for like protective purposes on the SDG&E system. Like it's a standardized piece of equipment for us, but its ability to independently control isolating positions is why we use it as a interconnection device, because we already have a relay controlling this. So now we just add in additional SDG&E logic to how we want to automate this system. So that's also part of the reason too why we choose to connect at this site, is also just familiarity with our protection engineers already work with this device, our DER engineers already work with this device. So we're able to build it into our standard logic, the ability to interconnect with these battery and microgrid systems.
Great. And on Borrego and Carmel, this comes from a user who didn't provide his or her name. How long will the Borrego and Carmel Valley, how long will they last during a power outage?
So we just had some planned maintenance on Borrego, where a transmission line was being worked on and being radially fed in like a non-microgrid scenario. We would have had to de-energize the community of Borrego, but we were able to actually use the microgrid. This is actually just in December, and we ran it for 12 hours, so all of the construction work could go on, or all the maintenance on this transmission line, and we had operators monitoring it, controlling it for 12 hours. So the customers did not have to be out for that duration. So that, I believe that's the longest we have operated it so far, but with Borrego, technically, as long as we right now kept having fuel for the generators, or if it was in the daytime and the solar was active, we can continue to prolong the duration of the outage. But that was a good use case of recently. Carmel Valley has not had to have been used as an emergency evacuation center yet, but we go out and we'll run it in island mode, do tests on it to just ensure it functions through its islanding operation as planned. So it hasn't actually in real life gone through those lengths that Borrego has.
Great, and Gregory from the Clean Coalition is asking, what grid isolation switch are you using for Carmel?
This Carmel Valley one is it's just a 4-way pad-mounted switch, and it's Trayer is the company we use, but there's other all of our energy storage system ones so far use Trayer, but there's other companies that make them. The special thing with this one though is we have like a fast close position on it. So if we are sinking back into the grid after being in an island, it's critical that we have the ability to close back in quickly so that we know once this side's synchronized to the grid, that's the moment we want to close back in. So that's actually one of the key features of this particular switch that we're utilizing. But each position is independently operated, and we use a SEL 487E in Carmel Valley specifically with logic in it to actually control all the automation and logic steps, or sorry, islanding steps or black start, depending on how we get into an island.
Wonderful, and that's a good point as any to end this Q&A session. I think you've answered plenty, and thank you so much, Kirsten, for sharing your presentation and all the work that SDG&E is doing on microgrids. And we hope you come back and present at another time.
Thank you so much for this opportunity, and yes, maybe we'll lead to some other technologies that we can share in the future. So yeah, we'll be sure to get back on those the pending questions, and actually one of my fellow coworkers was able to confirm that solar at Carmel Valley is 750 kilowatts. So thanks for the speedy reply on that one. But all the remaining questions, yes, we'll be sure to follow up. It was great talking with you all, and definitely feel free to reach out if you have any further questions. Actually forgot to put up the last slide with my email address on it, but feel free to reach out through the Clean Coalition and you can reach me. There you go.
There it is.
Thank you all.
Yeah.
There it is. So
if anyone wants to contact Kirsten directly, it's kpetersen@sdge.com. So from that, I just wanted to remind everybody once again, and those who arrived a little later, that we've got another webinar coming up on March 18th at the same time, identifying optimal locations for community microgrids. So we hope you all join that one. You can go on our website and register now, or we'll be sending out some email reminders. Gregory Young, who works at the Clean Coalition, will be presenting at that. And for this webinar, we're going to be sending out the recording tomorrow by the end of the day, and you can share it with your colleagues and share it on social media. That would be great. So thanks everybody, and thanks again, Kirsten.
Thank you.